Okay, number 65. We're getting into that latter third of the final exam review. And here's the problem we're presented with. We have inside the parentheses 2x cubed, and then that's raised to the second power.
Multiply the exponent.
We multiply the exponents. Very good, Becca.
Is anything raised, because if it's is anything raised to a power or something, you multiply them?
That's right. That's called the power rule, and that's a perfect way of explaining it. Now, one little reminder is the 2 also has an exponent, in this case 1. And so what you're going to distribute is you're going to distribute and multiply this external exponent of 2 to both of the internal exponents. So we can now get rid of the parentheses and write 2 raised to the power of 1 times 2, which is 2. And then x raised to the power of 3 times 2, which is 6. And then with the numerical base, we actually go ahead and find out what that is. 2 squared is 2 times 2, which is 4. So you end up with 4x to the 6th power. That's number 65. Now we're on number 66. We have 2x to the negative 4th power raised to the 4th power. So once again, we have to write in that exponent of 1 and then distribute, multiply this 4 to both of these terms. So that's going to give us 2 to the 4th power times x to the negative 4 times positive 4, which gives us negative 16. And we have to contend now with this negative exponent. The exponent rule is if I have a, some base a, raised to the power of negative m, then that's equal to 1 over a raised to the power of positive m. So applying that rule, the negative exponent rule, to this situation, I have x raised to the power of negative 16. So I'm going to write that like this. We'll deal with 2 to the 4th in a minute. I have 2 to the 4th times 1 over x to the positive 16 power. Now we got to deal with 2 to the 4th. That's 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we have 16 over x to the 16th power. Number 67, we're given x to the 4th over 2x to the 4th. So here I want to break our numbers away from our letters. Okay, so I have here 1x to the 4th over 2x to the 4th. This is really equal to 1/2 times x to the 4th over x to the 4th. And some of you may recognize that anything over itself is 1, but we're going to show the mathematics behind that. So down here, we're going to write the 1/2 again. But now I'm going to apply the division rule for exponents, which says when I'm dividing bases are the same, I subtract the exponents. So we're going to write 1/2, and then I'm just going to write an x here and put 4 minus 4. Okay, now that's going to give me 1/2 times x raised to the power of 0. This gives us a chance to remember the 0 exponent rule, which is basically any number or any letter, anything, raised to the power of 0 is equal to 1. So x to the power of 0 equals 1. So the math would be 1/2 times 1, which is just equal to 1/2. Now we're on to number 68. 3p over 3p to the 4th. Once again, I kind of want to break apart the numbers and the letters. So here I've got 3 to the 1st power over 3 to the 1st power times p to the 1st power over p to the 4th power. Okay, so that gives me 3 raised to the power of 1 minus 1 times p raised to the power of 1 minus 4, which gives me 3 raised to the power of 0 times p raised to the power of -3. So 3 raised to the power of 0 is 1. So that's 1 times p raised to the power of -3 is written 1 over p raised to the positive power of 3. And so the final answer would be 1 over p cubed, or p to the 3rd power. That's number 68. And number 69, things start to actually get interesting. We have a to the 4th power times 2a to the 3rd power times b raised to the power of 0. And then all of that is over big open parentheses here, a to the 4th power times b to the -1st power, close parentheses, and this whole parenthetical expression is raised to the -4th power. So it looks like quite a big task. But b to the 0, that's just 1. You understand? So I can kind of get rid of that. And then 1a to the 4th power times 2a to the 3rd power. This gives us an opportunity to apply the product rule for exponents, which states if the exponent bases are the same, we add the exponents. So here I'm going to rewrite this problem. I'm going to try to save what we need to do in the denominator for another step. But that's going to give me 1 times 2 is 2. And then a raised to the power of 4 plus 3. So that's a to the 7th. And that's the whole numerator now. And then in the denominator, what we need to do is distribute, multiply this -4 here and here. So in the denominator, I'm going to have a to the -16th power times b to the positive fourth power. And now I've got to contend with these a's, okay? So what I'm doing in my head is I'm saying, okay, a to the seventh minus negative 16. Okay, so what that looks like as a step, we can write this 2 kind of off by itself and deal with him in a second. And then we've got a raised to the power of 7 minus negative 16. And then this is all written over b to the fourth power. Okay, so now we have 7 minus negative 16. This is a plus. 7 plus 16 is 23. So down here, I've got 2a to the 23rd power over b to the fourth power. And that's how you do number 69. Number 70 gives us even more fun. Okay. So take a minute. You're going to have to write down number 70. It's quite a bit to write down. Maybe write small. You got the big open parentheses. 2x to the second, y to the 0, close parentheses, raised to the negative fourth, all over x to the fourth, y to the third, x to the negative first, y to the negative second. Okay, so we'll just take this one bite at a time. Remember your numbers, 2 here has an exponent of 1. So first we're going to distribute and multiply this negative 4 exponent to each of our terms in the numerator there. So for my numerator, I'm going to have 2 raised to the negative fourth power, x raised to the negative eighth power, and then y raised to the 0 times negative 4 is still 0. So this is going to be just a 1, so it can kind of be canceled out. So down in our denominator, I can apply the product rule for my x value. I've got x raised to the power of 4 plus negative 1. So that's 3. 4 minus 1 is 3. Or 4 plus negative 1 is 3. So x to the third power. And then y raised to the power of 3 plus negative 2, which just gives me 1. So y to the first can just be left as y. Well, now we have to deal with this negative exponent here, which is going to pull that 2 down into the denominator. We'll get to that in a second. And then I have x in the numerator and denominator, so I apply the division rule, and I'm going to subtract 3 from negative 8, which is going to give me negative 11. I'll show all these steps. So first things first. This 2 to the negative fourth is going to now become 1 over 2 to the fourth. Okay, so that deals with that. And now I have x raised to the power of negative 8 minus 3, which is negative 11. and then I have 1 over y, because that y was just hanging out in our denominator. Okay, so it kind of looks, for just a moment here, looks like I've made things harder. Now, x to the negative 11th is going to become 1 over x to the 11th. So basically, this is moving down into the denominator. And the only thing in the numerator will be a bunch of 1s. So the numerator is kind of a lonely 1 up here. And down in the denominator, I've got 2 to the 4th, which we already know is 16. So I'm going to write 16. X to the 11th, y. Okay, and that's fully simplified. Okay, that's number 70. And now we're moving into some problems that give us pictures. Number 71 is new type of problem. They give us that my x-intercept is 4 and my y-intercept is 3. Okay, so I'm looking for a picture where it crosses the x-axis at 1, 2, 3, 4, and the y-axis at 1, 2, 3. So the line that I draw will look like this. So you kind of pick the picture that looks like that. What do you think the answer is? A. Yeah. That's right. Okay. It's number 71. Number 72. I'm given an x-intercept at negative 4 and a y-intercept at negative 3. So the picture is that I'm crossing the x-axis at negative 1, 2, 3, 4, and the y-axis at negative 1, 2, 3. So my picture of my graph will look like this. Crossing at negative 4 and negative 3 is D. So I'll just show the picture there. B is crossing, it's flipped. So B is crossing the x at negative 3 and the y at negative 4. We want to be D. Okay. Okay. So now we're on to number 73. 5x plus y equals 5. All right. So this is number 73. You have to write this one down there. Do some work. 5x plus y equals 5. In order to know what this equation even looks like, we have to get this in slope-intercept form. Just a reminder, that's y equals mx plus b, where m is the slope and b is the y-intercept. And right now, our equation is in standard form, ax plus by equals c. Okay. So the procedure that we're going to follow is we're going to subtract ax from both sides. And then we'll have by equals negative ax plus c. And then we're going to divide everything by the coefficient of the y variable. And so y is going to be equal to negative a over bx plus c over b. It looks much harder when I'm just showing the letters because in our example, our y coefficient is 1. So that last step is very simple. But that's the game plan. So like I said, step 1 is to subtract 5x from both sides. Okay. Sometimes it helps to put a vertical line here to keep your work lined up. Okay, that's 0. So now I have y all by itself equals, we want to lead with this negative 5x plus 5. Okay, now there's multiple ways to figure out what this looks like. One way is to find the x and y intercepts. So if I want to find the x-intercept, I will do a problem here where I replace the y with a 0, and that's going to equal negative 5x plus 5, and just solve for x. So I'll subtract 5 from both sides. I'll have negative 5 equals negative 5x, and then divide both sides by the coefficient of the variable, which would be negative 5. And this is just 1, right? Equals x. So I'm crossing the x-axis at 1. And now to figure out where it crosses the y-axis, I replace the x with a 0. So I'll have y equals negative 5 times 0 plus 5. So negative 5 times 0 is 0. So y equals 5. So I'm crossing the x-axis at 1 and the y-axis at 5. Okay, so I'm crossing the x-axis at 1 and the y-axis at 1, 2, 3, 4, 5. So it's going to be a fairly steep line, like that, kind of a nearly vertical, going down as you move from right to left to right. What do you think, looking at the answer choices?
I think it's
C. Yeah, I agree. Okay. And number 74. And you're going to have to write this down. X plus y equals 5. Okay. Now I'll give you a little trick. We can actually just find the x and y intercepts here very easily. So for my x-intercept, I'll just replace the y with a 0. X plus 0 equals 5. So x equals 5. Well, that was easy. So it crosses the x-axis at 5. How about the y-intercept? Well, I'll replace the x with a 0. So that will be 0 plus y equals 5. And so both of my intercepts are 5. So my picture, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 will look like this. So looking back at the pictures, what do we think? D. It's D. Okay. Okay, now number 75 is a visual. So you just have to look up here y equals 2 is going to be a flat horizontal line passing through 2 on the y-axis. So which answer choice looks like that? A. Good. Number 76 is also visual. We want to look for a line that crosses the y-axis at 2 and has a negative slope. So from the left to the right, it's going to be going down, and it's going to cross the y-axis at positive 2. So which one looks like that? B. Okay? Good.
How many are we doing today?
We're going to do 2 more, then we're going to stop. And that'll get us through all of these graphs, and the next batch of problems will be inequalities. So we're just going to do these 2 more problems, and we're going to stop for today. So we're going to write this one down. 77, 5x minus 4y equals 0. Now I want to give you guys a chance to tell me, there's 2 ways to go about this. We can either plug in zeros for x and y and find those intercepts, or we can solve for y and attempt to use the slope-intercept form of the graph to visually identify the picture. What would you prefer? Would you say? The second one? Okay. So in that case, we're going to subtract 5x from both sides. Then we have negative 4y equals negative 5x. And we're going to divide both sides by the coefficient of the y variable. We're going to divide by negative 4. So y is going to equal positive 5 over 4 x. And this is important. When you don't see anything else over here, it means that the y-intercept is 0. So this is going to cross straight through the origin. And as you move from left to right, it's a positive slope. So it's going to be going from the origin. I'll show you how I would do it if I had no answer choices available and somebody told me to graph it. I would just start here and go up 5 over 4. Okay, and then I put my line like this. It's going to go straight through the origin. So looking at number 77, B or D? Yeah, it's going to be B. Yeah, because it goes up higher than it goes over. And on D, it's going up lower. It's going up higher less than it goes over. So I would say it's B. Okay. And so final question, number 78. Since we did number 77 using the solve for y, put it in slope-intercept form and then graph, let's do this one by plugging in our zeros and solving for the y-intercept and the x-intercept. So 78, you have negative 9y plus 45 equals 30 times x. Okay. So first, let's identify where it crosses the x-axis, which means we're going to replace that y with a 0. So we're finding our x-intercept here. We're going to write negative 9, open parentheses, 0, plus 45 equals 30x. Well, negative 9 times 0 is 0, so I have 45 equals 30x. So I want to divide by the coefficient of the x variable here. So I'm going to divide both sides by 30. These 30s cancel on the right, and so now reading from right to left, I have x equals, and now the greatest common factor of 45 and 30 is 15. If I divide both of these by 15, I'll have 3 over 2. So x is at 1.5. Okay, so it's halfway between 1 and 2. Okay, so my x-intercept is going to be 1.5. All right, so now I need to know the y-intercept. In this case, I'm going to replace x with a 0. So for my y-intercept, I'm going to write negative 9y plus 45 equals 30 times 0. So that gives me negative 9y plus 45 equals 0. So then I'll subtract 45 from both sides. And I'll have negative 9y equals negative 45. And I'll divide by the coefficient of the y variable. In this case, I'll divide both sides by negative 9. And y will equal positive 5. So my y-intercept is at 5. So a picture of this one, 2, so it's going to be right there. And then 1, 2, 3, 4, 5. Fairly steep, downward pointing, vertical looking line.
It will be B.
We look at our answer choices. I'm scanning, and I agree that B is the only thing that even comes close to looking like what we drew. All right, guys. So it's always fun at the very end to examine. The sound of backpacks is not the appropriate sound. We're not done working today. We're done working on this. So just to examine what we did, we ended at 78, and we started way back here at 65. So we went 65 all the way to 78. It's quite an accomplishment for one day's work. So it's a very good job, guys. I mean, you held it together. The discipline was good, and everybody was working hard. So excellent work.